All right, in this video, we are in the review session looking at example 3.16, which is found on slide 60. And what this tasks us with doing is working with a sample of distilled white vinegar, which you may or may not know, all vinegar is a solution of acetic acid. And we have the formula for acetic acid given to us right here, CH3CO2H in water. Okay? Depending on the strength of the solution, that'll depend on the strength of the vinegar. And we're given here a 0.500 liter solution of vinegar, which has 25.2 grams of acetic acid. This is a nice intro example for section 3.3, where we're solving for the molarity. Okay? Keeping in mind, right, that molarity, which we represent by the capital M, is equal to moles of solute over liters of SOL apostrophe N, which stands for solution. So molarity, which is represented by the capital M here, is equal to moles of solute over liters of solution. And in this situation, right, the acetic acid is the solute, and then it already tells us that the entire thing, right, it's called the vinegar solution. So to solve for the molarity here, we need moles of acetic acid over liters of solution. And the liters of the solution is easy because it tells us that right in the problem, right? 0.500 liter solution. But the problem here that we're going to have to be working with is how to solve for moles of solute. And we're only given one bit of information here to work with. And that's the fact that we have 25.2 grams of acetic acid. And I'm just going to start using the formula right here, CH3CO2H, that's acetic acid. Okay. And I have to take that grams and convert it to moles. Okay. And as you've seen in 3.1, we do that by using the formula mass. So I take that acetic acid and I break it apart into its constituent atoms. And this one can be a little bit tricky, okay, because everything's not grouped together. Look at the compound as a whole, CH3CO2H. There are 2 carbon atoms in there, right? And we're going to multiply them by the atomic mass of carbon. Okay, so 24.02 grams per mole total. Then we look at our hydrogens. There are 4 total hydrogens. So that equals to 4.032 grams per mole. And then we have 2 oxygens in there as well. So 2 times 16.00, which is going to give us 32.00 grams per mole. I add all of those together to get my formula mass of acetic acid, and that's going to come out to be 60.052 grams per mole. That is the formula mass of acetic acid, CH3CO2H. That's old news. We learned how to do that in 3.1. But now we need to use that formula mass back over here with my amount in grams to solve for moles. So I set up my conversion factor. I have grams of acetic acid to start, and I want that to go away. Okay. So grams of acetic acid is going to go down here. Sorry, I blew past my parentheses there. And I want to convert to moles of acetic acid. And we can always convert from grams to moles or moles to grams using the formula mass, which I just solved for. Right? It is 60.052 grams exactly in 1 mole. So I do that problem, right? 25.2 divided by 60.052 with 3 sig figs, I should have here, 25.2 is what's limiting me. So with 3 sig figs, I should have 0.420, okay, number's gonna round up just a bit, moles of acetic acid. And that is now what is going in that part of the problem right there. So now, to get my final answer for this problem, I'll rewrite it down here. Right? Molarity is equal to moles of solute divided by liters of solution. So that is going to be 0.420 moles of acetic acid divided by 0.500 liters of solution, which comes out to be 0.840 molar solution of acetic acid. And that is how you solve for molarity given grams and liters, keeping in mind that our volume amount was given to us in liters to begin with. If this was given to us in something else, we would want to solve for liters before we do our final calculation.